So, in terms of computation, what started as this is moving towards this, and in terms of memory, what started as this is moving towards this. But then I'm definitely not going to tell anything further about these, because this happens to be a session in which you are actually supposed to understand this. Yes, the Java's architecture, or in other words, you really have to understand as to what really the components of the JVM are. But then there are a host of new terms here. Until and unless all of these terms are clear, I'm sure you may not be able to understand as to what really is the JVM, and hence I had to give you some of the basics in as far as the computers are concerned. But still, there are a lot of terms that I would wish you to understand. You really have to understand the meanings of the term loader, linker, object file, executable file, library file, and a host of these terms if you really have to understand and appreciate the JVM. In other words, very quickly, I would take you towards giving more clarity towards these terms, and then moving on, explain to you the architecture of JVM. Understand all of these terms, what I now have to do is to give you a simple program to add two numbers. Yes, this is the program using which we can add two numbers. Of course, it's a C program, and hence I would wish to store it in a file called add.c. Well, if I would replace the printf with cout, then also replace stdio.h with iostream.h, then this becomes a C++ program, and obviously in that case I will have to save it in a file called as add.cpp. Nevertheless, whether it is a C program or a C++ program, this file would definitely be stored on the secondary memory, that is our hard disk. And you know, our computer is not just going to have the hard disk. It would have the RAM, it would have the microprocessor, it would have the input and the output devices. In fact, all of this put together is what we call as a computer. But then you also know that a computer is a lifeless hardware. Obviously, it doesn't have a life of its own. Rather, in order to make this lifeless hardware operational, we will have to install a software into this computer. In fact, such a software which makes our lifeless computer operational is what we call as an operating system. There are many operating systems available today, but then I assume that on my computer, the operating system that I have installed is the Windows operating system, and that is what is being depicted here. In fact, I can also communicate it this way, that my computer has Windows as the platform. Nevertheless, the challenge still remains that the program that I have coded is in the high-level language. After all, C and C++ happen to be high-level languages. But then, who really has to execute this program? It is the microprocessor, and you know very well that the microprocessor does not understand the high-level programming language. All that it understands is only the machine level. So what do we do? Let me proceed. Since I don't need the input and the output devices to continue further with my explanation, I am going to eliminate them. Nevertheless, the program which we have coded is in the high level and cannot be understood by the microprocessor, and hence I will have to feed my high level language program as an input to the compiler. The compiler would convert it to the machine level language code, and all of that machine level language code we would accumulate it and place it inside another file called the object file. While our source file was called as add.c, our object file would be called as add.obj. I'm sure you are noticing all of that, but then I want you to notice another important factor. If you would notice it carefully, you would realize that the color code that I have used for the object file is the same as the color code that I have used to represent the operating system. Why is it so? Let me tell you. Well, I have colored my object file in the same color as that of the operating system, only to indicate that it is such an object file which is compatible only with the Windows operating system. If in case it's confusing, let me give you two case studies. Just in case I was using a Macintosh operating system, then the same program using the same C compiler would have produced such an object file which would have been Macintosh compatible. It means that the binary codes present in this object file would have been such binary codes which would be compatible only with the Macintosh operating system. Similarly, just in case instead of the Macintosh I had made use of the Unix operating system, then the same program using the same C compiler would have produced such an object file which would have been Unix compatible. Well, that is the reason why we say that C compiler, or for that matter even the C++ compiler, happens to be platform dependent, or in other words we say that the C and the C++ compilers are going to produce such object files depending upon the platform on which the compilation is happening. In this case, since the compilation happened on the Windows operating system, the object file which was created also was a Windows compatible object file, and to indicate that I have colored my object file in the same color as that of my operating system. Nevertheless, if you now ask me a question whether the object file can now be sent to the microprocessor and executed, well, my answer would be no. I'm sure many of you are concerned because anyway, the object file contains the program in the machine level language. The microprocessor also understands machine level language. So why really can't we now send this file to the microprocessor and get it executed? Then my answer is going to be that yes, of course, the object file contains the program in the machine level language, but then I still can't execute it because it is an object file and not an executable file. And now I'm sure you have a question as to what really is the difference between the object file and the executable file. Let me clarify that. The difference between an object file and an executable file is that while we can execute the executable file, we cannot execute the object file. And if you'll ask me, why can't we execute the object file? That's because the object file is an incomplete file. Yes, this object file which contains the code in the machine level cannot be executed because it is incomplete. And if you'll ask me, why is the object file incomplete? That's because your source file itself is incomplete. Yes, look at the program which is there in your source file. Yes, the program is in high level, no doubt, but it's not a complete program, rather it's an incomplete program. And if you'll ask me, why is it an incomplete program? Well, the answer is that if you would carefully notice the program, you would realize that you are giving a call to the printf function, but you have never bothered to give the body of the printf function. Watch it carefully. Where have you provided the body of the printf? All that you have done in your program is that you have called the printf, but you never bothered to give the body. But then what you have intelligently told is that the body is present in the stdio library, so please include the body of the printf from the stdio library. That is what you are suggesting at the beginning of the program. Nevertheless, the point I want to communicate to you is that we may still go to the stdio library and take the body. That's a different issue. But as of now, if I would ask you, is this program a complete program? Definitely not, because you have only given a call to the printf, but you have not provided the body. In other words, my source file contains a program which is incomplete. Now, when my source file itself is incomplete, that incomplete program is what I gave as an input to my compiler, and the compiler obviously produced an object file, but then the object file also would be incomplete, and that is the reason why we cannot execute the contents of the object file. We first need to bring about completeness to the object file. Only after that we would be able to execute the program. In fact, bringing about completeness to the object file is what we call as converting the object file to an executable file. So how do we really do that? Let me explain. If I will have to convert this object file into an executable file, then I'll have to link my object file with the library files. But then, where is the library file? Well, as of now, you see no library files on the hard disk, but then I would wish to communicate to you that whenever you would have installed either the C language or the C++ language onto your computer, you would have also installed all the required library files. The stdio library files, the math library files, the conio library files, all of these library files, you would have installed it on the hard disk. These library files were always there on the hard disk, just that I had not shown them all this while. Nevertheless, if you would notice the library files carefully, you would realize that they are also color coded. What it means is that just in case you have Windows as your platform, then you should have installed onto your computer Windows compatible library files. Similarly, if in case your operating system was a Macintosh operating system, you should have installed Macintosh compatible library files, and similarly for the Unix operating system as well. Nevertheless, because it is the Windows operating system that I have now, I would have already installed the Windows compatible library files, and these happen to be those library files. And also, if some of my learners have a question as to what is the level of language in which these library files are coded, well, obviously the library files would be coded in the machine level language. That's because our object file is in the machine level language, and since we have to connect the object file with the library file, obviously the library files will have to be in the machine level language. Anyway, all that I now have to do is to link my object file with the required library files and obtain an executable file. And who does that? Well, we have a software to do that. That software is what we call as the linker. As the name itself suggests, it takes the object file as one of the inputs and the required library files as the other input, and is going to produce an executable file, and this happens to be our executable file. So if you now finally ask me that anyway that we have obtained the executable file, at least now can we send it to the microprocessor and execute? Yes, we are almost there, but just one more step is left. What is it? Let me tell you. One last step that is pending is for me to move my executable file from the secondary memory onto the primary memory. Obviously, I will have to move this onto the primary memory, or in other words, I have to move it onto the RAM, because you know that the microprocessor is not connected to the hard disk. After all, the microprocessor is connected to the RAM, and hence it is my duty to move my executable file from the secondary memory onto the primary memory. And who does that? Well, we have a software called as the loader. The loader is a software which is going to take the data from the hard disk and would be putting it onto the RAM. And once my program is on the RAM, it would send all the instructions present in it into the microprocessor, and the microprocessor would happily execute it and would produce the required result. Anyway, through all of this, you have been able to understand a lot of concepts such as the object file, the executable file, the library files, the loaders, the linkers, and so on. Now that you have been able to understand the meanings of the terms loaders, linkers, and all of that, well, again, if you would be having a look at the JVM, I'm sure now maybe you are able to identify a few terms there. But still, there are so many terms there which you still don't know the meaning of. Well, you might know as to what a compiler is, but definitely you don't know as to what an interpreter is.